So I have to say first, when I read Pierce's description, I thought, how can I survive being wrapped in plastic and cooked alive? Because it was about looking good laminated. Anyway, I'm going to talk today about storage and scalability. As long as there have been humans, humans have been creating information. And we keep building technology to store information, and we keep outgrowing this technology that we use to store information. And I don't think this is a trend that we can stop or reverse. And I'm not actually sure that we would want to stop or reverse it because it's become part of who we are. We just have to find a way to scale it. OK, who traveled to be here today? I actually don't have time to wait for you to raise your hands. I'm sorry. If you traveled here today, you're most likely holding one of these in your pocket. It's a room key. When you go to your hotel and you check in, they say, oh, Mr. Turk, you're in room 806 or whatever. They give you your key. It opens the door usually, and it's a simple thing, and it's a simple process. It's a little too complicated for me, though, because I can never remember my room number. So this is my trick. I take a photo of my room number when I'm leaving the room so I don't have to, later on, go down to the front desk and go, I'm stupid. I can't remember a number, because I can't remember a number. It doesn't work so well when you're in a place like Las Vegas, though, because the room number 85-32648 Tower 2, whatever, is not very helpful. Las Vegas is an interesting study, though, in how the hotel industry has taken the lessons from running a small hotel and they've applied them to running a big hotel by just scaling each individual task. More check-in people, more valets. But what if you had to build a hotel that had 1 million rooms in it? Could you hire enough people to process check-in for 1 million people at a time? Maybe, but probably not. What if you had to have a hotel with 1 billion rooms? Now you can forget having a front desk entirely. You can probably forget even knowing who's in your hotel at that point. The way you would run a hotel would be completely different. I know this doesn't make sense. It's going to. My trick also would not work in a hotel with 1 billion rooms because, I mean, so let's say I know my room is 18,462,322. So what? You know, I have the picture. It doesn't really help. So running a hotel with 1 billion rooms is problematic because also the hotel changes every single day you're there. If you have 1 billion rooms in your hotel, at any given moment, 100,000 of them are on fire, right? You know, 1 million of them are probably being renovated. You know, toilets don't work in half of them, whatever. And it's less like a building and more like an organism. It's changing all the time. So if you run this hotel with 1 billion rooms, every day you come into work, you're working for a different hotel, pretty much. So I explain all this to talk about scalability. What is the answer to this problem? More check-in clerks? More valets? Wider driveways? No, because the tricks you learn to make things big are not the same tricks you can apply to making things infinite. It's just different. It's a very different way of looking at things. So if I wanted to have a hotel with 1 billion rooms, maybe what you do is you figure out how to make the hotel itself assign people to rooms, right? Instead of having a centralized place, you procedurally do it, and the hotel grows itself through process, like a fractal. And so maybe this is, you come in and you put your thumbprint in an elevator, and it goes, oh, hey, you're Ross Turk, I recognize your shape, and I don't have a lookup table anywhere. I don't have a centralized registry, but I know you're in this room because I calculated that. And then when I come back on Tuesday, maybe it's a different room because there's been, like, I don't know, alien warfare and half the hotel's gone or whatever. And so it gives me a different room on Tuesday, but that's good because the robots have moved all my stuff from the old room to the new room, right? So as long as you have robots, you're good. So I guess what I'm saying is, in order to have a hotel with 1 billion rooms, you need two things. You need a deterministic, pseudo-random, repeatable placement algorithm that can put 1 billion people in 1 billion rooms and not mess up even once. And you need intelligent hotel rooms that can move people around, I don't know, liquefy them, put them in a tube, you know, whatever. And this exists today. It doesn't have anything to do with hotel rooms, but it's called CRUSH is the algorithm. It is controlled replication under shared hashing is what it stands for. And it's the way that Ceph, the open source distributed storage platform, figures out how to put data inside its cluster. So it's not hotel rooms, but it's the same problem. If you have an infinitely scalable storage system with an infinite number of nodes, and you can't write down where stuff is, you have to calculate where to put it and where to get it. So this is how CRUSH works. You call CRUSH, you pass it a cluster map and a series of placement rules, and it tells you, here's your data. It's in this node. And when you want to go put data somewhere, it tells you where to put it. And then the nodes are intelligent that if the cluster changes, it moves the data to where it should be so that when people calculate the next time, it's where they expect it to be. This is one of the things that you have to think about when you're building something that truly scales to infinity, and it's one of the things that makes Ceph a really interesting project to work on because it's solving problems in a different way. I haven't taken a breath in like 5 minutes. Okay, so the Ceph project is young, and it's vibrant, and it's growing. And if you believe, as I do, that this is an interesting problem to solve, and if you think that open source is the only right way to solve this problem, then we want to talk to you, and we're having a BOF in about an hour, and we invite you to join us.